So we are continuing our discussion of Python pandas today, and we have learned various methods and functions in Python pandas library so far. Today we will try to analyze a data set, and we will try to apply whatever we have learned on that particular data set to do some exploratory analysis. For that, I will first open a Python 3 file here. So this is untitled Python 3 file. This is exploratory data analysis on Penguins dataset. So there is a library called Seaborn library. First of all, we will import the necessary libraries. So import Seaborn as SNS. Either we can import the dataset from Seaborn library, or we can go to GitHub and we can find this CSV file, and using pandas we can import it. So we are going to do it with the help of Seaborn library. Now this Seaborn library is used for drawing different type of graphs also. Means if you have to visualize data using graphs, we use this Seaborn library. We will discuss it using some different type of plots. Today, first of all, we will learn how to load data sets that are there in the Seaborn library. So as you can see, a star was here and it is now gone. So now we can proceed further with uh, loading the data sets. So our data, so we have created a variable here, and sns dot load underscore dataset. So in Seaborn library we have this method which is called load underscore dataset, and here we can provide name of various datasets. So the name of dataset that we are going to load today is Penguins dataset. So on Google, if you will type Seaborn datasets, so it will bring you to this GitHub profile, and here you will see name of these datasets. Okay, so you can see all these: rename Messi anagrams dataset, attention dataset, brain network dataset, 534 538 car crash dataset, diamonds dataset, dot dataset. All of these datasets are very much helpful for learning exploratory data analysis. These are very much helpful for doing or for applying machine learning on them, for applying classification or regression machine learning algorithms on them. For example, this iris dataset is very famous dataset, but today we are discussing this penguins dataset. So now that's why we have written penguins here. Suppose you want to load iris, so you can write iris here, and you just have to write the name of dataset. Now I have saved the dataset in the data variable. So now when you will print the data, you will see these variables here. Okay, so this is basically data about penguins. So there are three species of penguin. So their names are Gentoo, Adelie, and Chin Strap. Okay, so these are the three species which uh, which are found in these islands. So there are some islands also, and this is the bill length of penguin. So again, if you will do some Google search and look for bill length of penguin, so you will find some image explaining bill length.
Yeah.
So you will see like this, right? This image is of Tableau public, right? So uh, let's see the image here. So you can find this image on this link, and here you will understand the bill length and bill depth. So if you will find a penguin and if you will try to measure its bill length and bill depth, so you will you will be able to guess the species of penguin. Okay, similarly
Okay.
there is flipper length. So one more parameter they are talking about is flipper length. So obviously we know what flipper length is, right? So this is the flipper part. So they are also measuring the flipper length. So this is bill length, bill depth, and flipper length. And this is foot length. They are not considering foot length in this example.
Okay.
And also they are measuring the body mass in grams. Okay. And
Okay.
because I think this data is collected by the scientists, so they have knowledge about penguin, so they can also tell the gender of that penguin on the basis of its body structure. So we know these parameters about penguins. Okay, now in this particular example, let's say a species is our output parameter. Okay, and all these are our input parameters, which simply means on the basis of this data that we have here, if you will try to find out what is species of penguin, suppose we find a new penguin, suppose we are going somewhere or we are doing some research and we find a new penguin and we measure these parameters of that penguin. So with the help of model that we will create from this data, we will be able to tell the species of that penguin, right? So
Yeah.
that will be taught to you in the chapter of machine learning, where we will apply different type of classification based algorithms. But today we are just doing some exploratory analysis. We are just discussing whatever we have discussed so far, and we are trying to apply it here. So next the thing is, here you can see some NaN values are there. So first of all, this is our data and we will do data.info. Okay, so this info is very much helpful. Sorry brother. So if you will run data.info, so you will see here that we have these 7 columns. Okay, at number
Yeah.
0 we have species, at number 6 we have gender, sex they are calling it. So here you will see, because we have total 344 entries. Okay, so this
Okay.
info will give us information of the data type, but it will also give a valued information about how many available values we have, right? So here you can see in sex column we don't have 11 values, means 11 values are missing, means there are 11 such penguins of which we don't have the data about their gender. Okay,
Okay.
so those values will be written as NaN. Okay, not a
Okay.
number. So we have already discussed, if you have to deal with NaN values, then there are different methods. The first method is, let's say df is equal to data. So we are just saving it as df because we have habit of doing this. So this is our data frame. Now remember, although we have not imported pandas here, okay, but
Okay.
the output of this particular equation that we are saving here is a data frame. Okay, so
Okay.
in Cbon it is kind of inbuilt that whenever you will create a load data set, So it will always be a pandas data frame. Okay. So now if you will do it df dot drop na. Okay. So because we have not specified any column here, right? So
Yeah.
because we have not specified any column here, so if in any particular row, if there is any column which has any n values, so that column will or that row will be dropped. Okay. So now you
Okay.
will see that we have only 333 rows. Why we have 333 rows? Because
11 has more genders.
in gender we have only 333 valid values, right? So
Okay.
on the base, so out of 344, if suppose we have 333 values, I think that is sufficient for us, right? Because we are losing only 11 values, and now we still have pretty much the original data, right? We are not
Yeah.
manipulating this data. Now another way of doing this is we can also do df dot fill na. Okay. Suppose we don't want to lose the 11 values, so we can do method is equal to f fill. Okay. So here what will happen, you can see here, right? Our fourth value was missing, right? This
Yeah.
fourth value has no information of bin length or depth or whatever. So this fourth value was missing, but now this fourth value has previous values, right? Because we have used the forward fill method. Similarly, we can use the b fill method also, right? If you will use the b fill method, then it will copy the next values into the previous value. So it will copy the value from fourth index into the third index. Okay. So either you can do this or you can simply do drop na. Okay. So this is what we learned in the chapter of handling missing data. Now let's say we are going with df dot drop na. Okay. So this is going to be our new data set, right? So that's why we will call it df is equal to df dot drop na. So now in df dot drop na, if you will do df dot shape, so what is the main purpose of this parameter shape? It gives you a tuple output, and the output contains number of columns, number of rows and number of columns. Okay. So it is
Okay.
clearly telling us that there are 7 columns
Columns.
and 333 rows,
Rows.
and we are sure that no column has NaN values. Okay. So that's why we are sticking with the drop Na. So you will see that in some other example, fill Na might work very well, right? Fill Na method f fill might work very well. In some case, df dot interpolate might work very well, right? So it
Yeah.
depends from case to case, and all of these methods are very important for handling missing data. So this is the first thing that we have done so far. Now the next thing is I will write down some headings here. Okay. How many species are there? So isn't it a valid question, right? How many
Yeah.
species are there? And most importantly, how many members of each species are there, right? So
Yeah.
originally in the data set, so this is the original data set, right? if if someone is asking you how many species are there, so it is simply asking you to count the values of each species, right? And for
Yeah.
that we have value underscore count method, right? So first of all we have to select the column data dot species dot value underscore counts. Okay.
Um,
So I told you that first of all you have to select a series in which you have to count the number of values of each element, and this is data. Okay. And this here, let's talk about df. So we will also understand that here you will see that from Gentoo five uh, five penguins are dropped, okay, and from Adelaide six penguins are dropped, right? So
Yeah.
now we this is our final data kind of, right? So which we are trying to analyze here. This is our final data. So similarly we can also tell how many islands are there, right? So if you have to tell how many islands are there, so then also you can do the same thing. You just have to write df dot island dot value underscore. I think it is islands.
Okay.
Yes, let's see island. I think I wrote the wrong spelling of it. So this. Now there is one more thing. If you have to present this type of data graphically, so you can also write plot here, and in plot you can write kind is equal to bar, okay.
Okay.
So when you will write kind is equal to bar, it will give you this type of graph, okay. So
Okay.
here it is telling us Visco, Dream and Torgerson, whatever their names are, and here we are seeing that the color is blue, right?
Yeah.
So we can put a comma here, and we can write another parameter here which is called color, okay. And in color we can create a list here, okay. And in this list we can put three elements, let's say R, G and B. So red stands for, R stands for red, G stands for green and blue, okay. So suppose you have more members, so either you can provide a list of required colors, okay, or
Okay.
if you will provide only two colors, let's say, so those two colors will be repeated throughout the graph. We will see that in some other example. Now there is one more parameter that you can provide here. That parameter is called title, okay. So what we have done here is, whenever you will do value underscore counts, so it will give you total number of values in each category, okay. And just after that you can put a plot variable here. In plot method, in plot method there is a parameter called kind. So we have put bar here, we will see more examples in this very chapter. Then we have color, inside color we can put something like this. Then we have title also, okay. So what is the title of this thing here? It is how many islands are there. So now you have this. If you want, you can save this image, right? And you can create a document file in which you can put these images. And we also learned we can programmatically save these images also, right? In PNG
Yeah.
format or in JPG format, whatever we want. So that is up to you, but because this is Jupyter notebook in itself is for exploratory analysis, and it is self-explanatory, right? We can download this file as HTML, so anyone can view it any browser, right? Now third column that we can analyze here. So you can see these two columns are object values. These two columns have uh, you know repetitive values, right? We have some classes here, and similarly this sex column is also here, which has repetitive values. So now we will try to find out how many penguins are there in each gender. Okay, so here what we have to do, we can also put this as markdown. So we are just either, when we have to execute our code, we can put it as code, or we can put it as markdown. So if you will write a hashtag and then you will do the markdown, it will become a bigger heading. Okay,
Okay.
now again df dot sex dot value underscore counts. Okay, and here we are getting these values. It is almost pretty much the same percentage, but we have more male penguins here. Now here we will try to draw a pie chart. Okay, so suppose we have to tell percentage of male versus percentage of female. So that can be done using a pie chart. So plot, in plot the first parameter is kind, and kind is equal to pi here. Okay, and then we have to provide the title, right? So we will put this very title here. Then there is a very, so let me put title last. Then we have to use fig size. Okay, we have to remember this parameter also, it is called fig size. What is meaning of fig size? It is figure size. Okay,
Figures. Okay.
and here also we have to create a list. So this first parameter is your height, or sorry, width, and the second parameter is your height. So let's put it this way, 10 comma 4. First of all we will try to create a graph like this. So you can see here, right? Here it is giving us a this circle. So actually in case of pie chart we always use something like this, 8 comma 8 or 6 comma 6. Okay, so this is our pie chart. Now let's try to fit fig size here. Fig size is equal to 10 comma 4. Now you will see that its length will increase and its height will almost remain the same, right? So this is 10 comma 4, and here it is 6 comma 6.
Six.
Now we are going to use another parameter here, auto PCT is equal. So first of all you will get this notebook with you. You will also get this video as a reference. Okay,
Okay.
auto PCT is equal to, what is auto PCT? Auto PCT stands for percentage, automatic percentage maybe, and here you have to provide percentage. Okay, percent point 2f. This 2f stands for two float decimal points, right?
Okay.
Means it is going to be a float value with two decimal points. Let's try
Okay.
this, right? So
Okay.
it is now showing us that in this data set 50% of penguins are male, 50.45% of penguins are male, and 49.5 are
Okay.
penguins. So we can say it is
Yeah.
very much evenly matched data, right? Let's
Yeah.
write 4F here. So you will see
Okay.
it is now giving
Four
us
decimals of.
more precise value, right? Up to 4
Okay.
decimal places. So it simply means that it is going to be a float value with these many decimal places, right?
Okay.
So 2F is very much sufficient, I think. So that's why we mostly write 2F. Suppose you want to get more close and precise values, then in that case you can use 4F or 5F, whatever you want. Okay. So this is how we draw pie chart, and this is how we draw a bar chart. Okay.
Okay.
And we have discussed drop NA, fill NA, and shape method here also. Okay. Now this time we will try to analyze how bill length, bill length varies with respect to body mass, or body mass varies with respect to bill length, right? So we will pick any two parameters that are numerical here, right? And these are continuous values, and we will try to analyze what is the relationship between them. Okay, what is the relationship between bill length and body mass? Okay, so first of all we will write SNS. Okay, which is short for seaborn. Okay, because we have imported
Okay.
seaborn as SNS, and because we want to see relationship between two variables, right? So we have this plot called a rel plot. Okay, this is relation plot, you can say. So in seaborn library there are different type of plots, like rel plot is there, lm plot is there. Okay, and we will ylen chart and different type of charts are there. We will discuss them. Now in the rel plot there are several parameters. Okay, because it is used for displaying relationship between two variables. Okay, so here first of all you have to write data is equal to what. Okay, so the data here means name of your data frame. Okay, so the name of our data frame is df. In this data frame, because when we draw a graph we draw it between x and y, right? So on x axis we will take one variable, on y axis we will take another variable, and then we will try to plot a graph between them. So let's say we are taking bill length as the independent parameter. Okay, so we are just trying to find out if bill length increases, does body mass also increase. Okay, so this. So now can you understand what is written here? SNS.rel plot, right?
Yeah.
It has three parameters. Data is equal to df,
So that
x is equal
x
to
equal to.
so you have to write the correct name of column here. In
Okay.
y also you have to write the correct name of column, and when you will do this, so you will see a graph like this. Okay,
Okay.
which will kind of give you a relationship between these two variables. So you can see when bill length is increasing, so in some cases the
Body mass
body
is
mass is
increased.
also increasing, right?
Yeah.
although in some cases you can see when bill length is more, body mass is not has not increased that much. But again, if you will tell on the basis of this complete data, you will see that when bill length is increasing, body mass is also increasing. Okay. Similarly, you can find out relationship between other variables also. Okay. Let's try to find out a relationship between flipper length and body mass. Okay. And why we are discussing these parameters, I will just tell you. So here you can see we have more significant proof of that when flipper length is increasing, body mass is increasing, right? So
Yeah.
this gives us a more clearer view. Now there is a very important parameter here in rel plot, and that parameter is called as hue. So hue is basically color. Okay.
Okay.
So let's put gender here inside hue. So you will see this, right? So now you will be able to visualize the data with with the help of color. Okay. Means you will be able to distinguish where female penguins are there and where male penguins are there with, and when we are trying to, you know, find out relationship between the body mass and bill length, right? Getting it?
Yes, thank you.
And here also you can do the same thing. So with the help of this, suppose gender is our output parameter, let's say. So you will be able to see some clustering of data. Okay. Means you will be able to find some clusters. Means in some places you will see there are more number of female penguins. In some cases there are more number of male penguins, right? Now on this, in this same relationship, instead of gender, we can also put other categorical variables also, right? Means other variables like, because species is our output, right? We have gain to chin
Yeah.
strap and a daily. So here you will see that it is very easy to distinguish Gentoo from other penguins, right? If we will consider these two variables, are you getting my point or not?
Yes.
If
Yes.
if we will consider these two parameters like flipper length and body mass, then we will be able to distinguish Gentoo very easily. You can see
Great.
when the flipper length is approximately more than 208 or
15.
9 millimeters, and when the body mass is more than 4000 grams or 4 kilograms, so it is quite a possibility that that penguin is of Gentoo species, right?
Yeah.
But between Adelie and chin strap, we cannot tell uh, from these parameters very easily, right? From these variables, we cannot tell about these two penguins. Now, let's try species here also between these two variables. So we will put a species here also, and this hue is very, and now you will understand. Now see this data. Here you can very easily see three clusters, right? Means you can also set boundaries for them, yes or no,
Yeah.
right? So you can easily say that when bill length is less and body mass is less, those penguins are Adelie, right? When bill length is more and body mass is less, so in that case those penguins are chin strap. And when bill length and body mass are on higher side, we have then we have Gentoo. So the thing is, with the help of these two relationships, we can tell that all of these variables are important in finding uh, the output, right? In finding which penguin is there,
Yes.
in distinguishing between them or classifying them. Now let's, instead of bill length, let's take another parameter here, bill depth. Okay, because this parameter is also remaining. So when you will plot a graph between bill depth and body mass, then you can, you can tell more easily between again two, but other penguins are kind of mixed together. And between bill depth and, let's say, bill, there is one more relation that we can do. So bill depth and bill length okay, LENG. So between bill depth and bill length also we can, you know classify different type of penguins, right? So
Yeah.
that's why these numerical variables are very important, because on the
Okay.
basis of relationship between these numerical variables, we will be able to find out what species of penguin is there, right? And most
Yeah.
important thing is there, suppose we find a new penguin, right? So, and
Yeah.
we calculate its bill length, we calculate its bill depth, flipper length and body mass, okay? And then if you will try to, you know draw, or if you will put that penguin on these coordinates, right? Suppose, let's take a screenshot here. So I'm simply taking a screenshot here. Suppose we found a penguin with bill depth of 18 mm. Okay, we are just assuming this. Its bill depth was 18 mm, and let's say its bill length was 55 mm. Okay, so this is BD and this is BL, bill depth, bill length. Okay, so bill depth 18 mm. Let's draw a straight line here, right? I will draw a line with this much thickness, and bill length is 55. Okay, so
Okay.
that penguin will come at this particular point. So with more confidence, what will be your output? Will you classify it as Gentoo, chain strap, or Adelie?
Yeah. Like if the build-up is greater than 18 and bill length is greater than around 45,
Yeah,
so then we can consider that as N2.
yeah. But here, when we are plotting this graph, you will see that means, so here, as per my assumption, it will be classified as chin strap. Okay, because in this particular region, more chin straps are there. So
Yeah.
now there are. That's why there are different type of algorithms. Okay,
Okay.
So there is a library called sklearn library. So these libraries will ask you different inputs and output. Okay, they will, and on the basis of that they will try to create a model which will try to predict. On the basis of these numerical values, it will try to predict in which particular species will this penguin belong, right?
Yeah.
And then the data that we are visualizing right now is on 2 dimension only, right? So actually there are 4 variables, right? So some sort of relationship can be gathered between each variable.
Okay.
Now there is one more thing. In SNS there is a plot called pair plot. Okay, here you have to write data as df, means this is our data, and hue is equal to species. Okay, so this pair plot, now what we are doing here is we were just trying to take all the numerical variables and we were trying to draw relationship between all these numerical variables with each other. Okay, so
Okay.
this pair plot will do it for you in one go. Okay, so whatever we were trying to achieve there, it will do the same thing in one plot itself. Now you will see. Let's uh, copy this image link and visualize it in a new browser. Just a minute. Just a minute. So this is our graph. Okay,
Okay.
this first column is bill length, and this is the distribution of data of penguins, right? This is
Okay.
distribution of how bill length is distributed in the data set. Okay, and
Okay.
means you can see Adelie penguins have lower bill length, right? The
Yeah.
the bill length is lower in case of Adelie. In case of chain strap and in case of Gentoo, it is almost the same. But we have more penguins of Gentoo, right? This
Yeah.
height represents more number of penguins, right? And here you will see that bill length is an important parameter, because when we are drawing relationship with other variables, so we are able to, means clearly able to see 3 clusters here, right? So bill length is going to be our important parameter for us. Similarly, there is bill depth. In case of bill depth, you cannot say the same thing, because in case of bill depth, you can see when we are trying to plot relationship between with other variables, so bill depth is not very conclusive. And similarly, we have these parameters also. So on the basis of these graphs, you will be able to tell that with the help of this first line, right, means with the help of relationship between bill length with bill depth, bill length with body mass, and bill length with flipper length. Okay, so all these parameters can be used to clearly distinguish what a species of penguin is there, right? So this type of graph is called pair plot. It is basically the relationship plot, but here we don't have to manually draw relationship plot with one variable with each variable. We can simply just create a pair plot, and it will take all the numerical variables and it will try to create a grid here where you will have rel plot of each variable with other variable. And in hue we have put a species. Hue simply means color, so we have color here, right? So this is our simple exploratory data analysis here, right? And this is how you can analyze other different type of data sets also. We will try to analyze data with other type of functions also. Now for example, we discussed group by. Okay, so this time we will try to find out average bill length in each species. Now how can you do that? Means what type of approach can we follow to do this? So first of all, what we are going to do, df dot group by, because we want to find average bill length in each species, so we will do group by, and inside group by we will write species. Okay,
Okay.
getting it? Not getting it or not means,
Yeah.
so let's say, let's call it grps. This is group species. Now grps dot mean, if you will write this, right, so then you will find out that actually we are getting mean of all the numerical variables here, right? So you can clearly tell that average bill length in chin strap is more, right? It is almost 49. In Gentoo it is 47, and in Adeli it is 38, right? So you can
Yes.
say that this is average, right? Mean. Similarly,
Yeah.
we can also find out maximum, right? So actually in case of maximum and minimum, this island is also coming in, it is coming with respect to their alphabetical order, right? Then minimum is there. Actually we have to ignore this island thing here in gender here, because in max and min these numerical values and the object values are also considered. Similarly, you can also find standard deviation, right? So you can see the standard deviation is also more in case of chin strap, in bill length. In case of body mass, the deviation is more in case of Gentoo, right? In case of flipper length, the standard deviation is more in case of flipper length, chin strap, right? So this is basically how we analyze data. This is basically how we explore data, right?
Yeah.
So these methods and everything that we have discussed here, we discussed it on some example data sets, right, separately. Now on one particular data set we have kind of applied all that, right, and we have tried to find out some more useful insights from this data, right? So now I will save this file as HTML. So you can always save this file as HTML, so that if someone does not have Anaconda Navigator, then they can open these files on any browser. So if you will simply click this HTML file, so you will be able to analyze or at least read it in any particular browser. Okay,
Okay.
so now it's your turn. You can go ahead and apply these parameters. You can apply more parameters which you have studied so far. Okay, and you can Also try to find out more useful insights from this data, and then you can share it with us, right? And this video will always be there to go back and try things as discussed in the video. Okay.
Okay.